Metro University. His area of expertise are business development, marketing and large accountant management, strategic alliance or partnership management. He have worked on leadership roles like GM, Head of Sales and Marketing in various companies like National Aerospace Laboratories, Access Skates, Chivaro Technologies, Hinduja Tech Limited, Firachow Engineering. Some of his achievements are as a leader have contributed significantly towards marketing activities in the region of working in collaboration with Markout team in Germany, led the role for acquiring new global MNC for the region such as Airbus, OKI and Continental. Played a key role for best cost country mission in Germany to promote India as the best cost country offshore destination inside Fairchow Engineering. I welcome you for this panel, sir.
Thank you.
Our third panelist is Mr. Pavan Kumar, Senior Vice President, Altair, Bengaluru. Mr. Pavan Kumar completed his education in Mangaluru University and Masters in TMAPI Management Institute. Mr. Pavan is a dynamic leader, techno-commercial professional, and a sales strategist with a successful track record of delivering profitable growth and building market leadership for global companies with over 32 years of experience. He worked in various companies like Autodesk India, SGI, OMC Computer Limited. Mr. Pavan is currently responsible for Altair's indirect business of Altair simulation-driven design and data analytic tools globally. He has also been active in various industry associations and is a past chairman of Indo-American Chamber of Commerce, Karnataka. I heartily welcome you for this panel, sir.
Thank you.
Our fourth panelist is Ms. Ujjaini Mitra, founder and CEO of the DeltaCube.ai. Ms. Ujjaini Mitra completed her education in Chennai Mathematical Institution and Indian Statistical Institute, Kolkata. She has 14 years of rich leadership experience in establishing data as a culture and large organization. Her work experience is spread over the globe across industries like digital media and entertainment, e-commerce, telecommunication, CPG, healthcare, retail banking, travel, and hospitality business, both B2C and B2B, to name few. Ms. Ujjaini Mitra worked on leader roles in Supervise, Z Entertainment, Z5, Flipkart, Airtel, to name few. Some of her honors and awards are one among top 5 leadership explorer facilitator in Jagriti Yatra 2015. She is the 50 most influential women in the media, marketing and advertising. Greatest female AI influencer in the data science world 2021. I heartily welcome you for this panel, ma'am.
Thank you so much.
Our fifth panelist is Mr. Shailesh Agrahari, R&D and People Leader, Philips, Pune. Mr. Shailesh completed his education in NIT Calicut and Masters in University of Toledo and Grand Valley State University. He is result-oriented R&D leader with 20 plus years of global experience in the area of end-to-end new product development, people leadership, innovation, and strategic product portfolio management and manufacturing operations. He worked in various companies like Shape Corporation Engineering, Innovation and System, Bajaj Auto Limited. I welcome you, sir, for being a part of this panel.
Thank you.
I would also like to welcome our beloved principal, Dr. Niranjan N. Chiplunkar, for gracing this event with his presence. I welcome you, sir.
Thank you.
I welcome the moderator of this panel discussion, Dr. Shashikant Karinka, sir, Professor, Department of Mechanical Engineering, NMAMIT Nitte. I also welcome our organizers, Dr. Anil Kumar HS, Dr. Ajit M. Hebbard, and members of IIC NMAMIT Nitte for this panel discussion. Now I request our principal, Dr. Niranjan N. Chiplunkar, to give the opening remarks for this event.
Yeah.
Off to you, sir.
Good afternoon. Galaxy of panelists who have responded to our invitation for being there on today's panel discussion on benefits and limitations of data science in design thinking. The moderator of this panel discussion, Dr. Shashikant Tarinka, chairperson and the members of Institution Innovation Council of our college, all the faculty members and the attendees of this particular panel discussion. At the outset, I wish to thank, on behalf of our institute, on behalf of our institution, all the panelists for accepting this invitation for being there. And I hope and wish that this panel discussion will definitely be very, fruitful one, and then all the attendees of this particular panel discussion will get a lot of inputs to their deliberations. NMAMIT Institute of Technology, Nitte, is on the west coast of Karnataka, about 20 kilometers away from Arabian Sea. And we are a private autonomous engineering college affiliated to Vishwesvaraya Technological University, Belagavi. And we started in the year 1986, and we have about 10 undergraduate programs. One more we may start in the coming academic year. And we have MCA, MBA, and then 6 MTech programs. There are more than 5,500 students in the campus. And we have started courses on artificial intelligence and machine learning, an undergraduate program. Artificial intelligence and data science, we plan to start from next year. We are a NAC A-grade institution, and all our undergraduate programs are MBA accredited. And we were placed in platinum category in the CII ranking for continuous 3 years. In fact, we have been conducting very many such programs. In fact, we wanted to have the presence of all eminent panelists on our campus, but I know it's very difficult to travel, and also I take this opportunity to invite all of you, whenever you find time, please do visit our institution. We have 14 centers of excellence, and our management headed by Sri Vinay Hegde, who is the President of Nitte Education Trust and Chancellor of Nitte Deemed University at Mangalore. He is also the chairman of our governing council. Our management is very proactive, and then they want to do everything that is required for the benefit of students' learning. Coming to this particular panel discussion in particular, I'm not an expert, of course, on design thinking as well as data science, but I'm a professor in computer science and engineering. So with little bit whatever I have understood out of these two domains, for computer science professionals, the designing, actually they study right in the their engineering in the software design, where they go through a very methodical process of designing any software. But design thinking, as I understand, is not limited only to software design, but it is across all the applications. And a human-centered approach of design is what is basically talked about in design thinking. That's what I understood. And data science, we all know, is basically wherein we gather a lot of data, and which will help us in making lots of decisions. So in this particular panel discussion, it's a very apt subject where both data science and design thinking, their interdependences, both pluses and minuses, are going to be discussed. In fact, when I was talking to somebody else on the other day, I was just quoting two examples of how certain designs may not be that comfortable for a user when he uses that particular apparatus. For example, in a laptop, we will have USB ports both on left side, right side. Some even there are USB ports on the back of the laptop and all that. If it's a left-hander, definitely for him to insert any USB drives or anything that is to the USB port, a USB port on the left of the laptop may become more easier, instead of he turning and then inserting it on the right hand side. So maybe the user's input also may be very necessary while designing such options which are given on the laptops. And most of us, I'm sure, have tried multiple times while we insert the pen drives onto the USB port. We turn it once, and then finally we will be able to fix it up. So lots of user conveniences have to be evaluated whenever we design a lot of things. And I believe in this particular panel discussion, all the learned panelists will throw light on different aspects of data science and design thinking. I wish that this entire 1.5 hours program will be a success and the benefit of this will reach to all the needy people. I thank IIC of NMAMIT and also the moderator, Dr. Shashikant Karinka, who has really worked hard in getting contact of all the panelists and then making this a reality. Thanking once again all of you. I wish the program every success. Thank you very much.
Thank you, sir, for your wishes. Now I request Dr. Shashikant Karinka, sir, to proceed with the panel discussion. Off to you, sir.
Okay, thank you, Ms. Ankita, and thanks to Principal Sir for giving the opening remarks. Now we'll start the session with a presentation by Sri Girish Samal. So he is from Merit Head Sales and Marketing, Bengaluru. So please start the session with your presentation. My key connection in this regard is Mr. Girish. So we worked together in making this a success.
Thank you. So is it visible now?
Yeah, but you have to make it full screen like we discussed earlier.
Right.
Yeah, I think this is okay.
So my audio is correct?
Yes.
Okay. So I thank you, NMAMIT team for organizing this, and I am delighted to be part of this panelists and eminent industry veterans, and it is an opportunity to share the experience and knowledge that we have gained. And data science and design thinking are a lot of commonalities are there. And in fact, we will be talking more about it. But my presentation is very short and crispy. And I will straight away, maybe 7-8 slides or 10 slides max. So I will take you straight away to challenge your thinking process about design thinking. Like what could be the design thinking framework that, we start with nothing, or maybe we start with uncertainty and we want to end up with some clarity and concrete design finished product. That is the objective of design thinking. So be it in any field. So for easy understanding, I will take you through mechanical engineering product design, which will give you very tangible and easy understanding. So we start with a lot of things like uncertain about the finished products, and there are different stages and processes that we undergo in order to arrive at an end product which is developed and functionally meeting the requirements. So there are 5 basic steps involved in the design thinking. We start from empathizing, then we go through different steps like defining, ideating, prototyping, and testing. And eventually, if required, we go for iterations, not only one time, could be several times. So as an empathizing, in empathizing stage, we try to learn from audience and understand their sufferings or requirements, like what is the exact problem is, we want to understand that. And then we understand the challenges involved in that. Then we go to defining the problem, what is exactly, like we get a lot of problems, lot of information, then we slowly we converge to define it. What are the functionalities, what are the requirements, what is the scope, what could be the strategy of developing the products, what is the final set of features or specifications we are looking for. So we try to freeze the requirement at this stage after understanding or empathizing the problems that we came across. Then we go to the next stage where, it is ideating or generating ideas or possibilities of different solutions. So we may end up with different sketchings, brainstorming different ideas, different structures. So that is like a rough stage. We come out, and from there we build, keeping in mind the functionalities and requirements. We go for developing the proto, and then we go to prototype development. And when we create a scaled version of the original version, and we try to see if everything is okay, all right, meeting the requirements. Sometimes we go for testing the prototyping as well, and then we go for final product development. And in the final product development, once it is done, we go for again reiterating, understanding users experience, let them use the product to understand the feedbacks or the problems, or how it is addressing their requirements. So I'll take you to one product that we developed in Merit. In Merit, we developed a product which is which is oxygen concentrator, and it is in collaboration with the Indian Institute of Science and Society for Innovation and Development. In fact, SID is incubation center of IISc, and Merit was technology integrator for this smart product. And this product, which is like, during the pandemic, it was very much important and required. In fact, Karnataka government actually sponsored this or pushed IISc to go for this indigenously built product. And Merit played a key role by being a technology integrator. So we underwent different stages of product development or design thinking. We understood the market situation, or maybe from, being a pharmaceutical product, we have to understand from the user perspective or requirement perspective very well. So we understood the quantity of oxygen, then keeping in mind it should be light, portable, and you can carry it easily. And we tried to, around that, we defined the requirements. Then we found out WHO, World Health Organization's standards and specifications. And then for different products, like we developed two sets of products. One is for 5 liter, another is 10 liter. So for two products, there is a different set of requirements, be it weight wise, be it the oxygen concentration wise, flow wise. So we have to freeze all the requirements, specifications at the stage of defining it. And when the requirements are defined and frozen, we went to go for ideating. And in fact, during define stage, we compared this product or our so-called ideas with the available products for benchmarking purpose, and then comparing the different specifications that are available with competitors, be it our colleague who is here, like Soilless company, Philips, or be it BPL, or be it other Chinese products as well. So we tried to compare it with the different organizations, competitions, products, then their qualities, their requirements, their outcomes, and their cost, their quality, be it reliability, be it safety, be it, all those ergonomic factors. We compare everything. Then we set the benchmark and fix the target. This is what we want to do. But well, if we want to do that, how do we go about it? What could be the ideal product that we are going to have it? So that was the brainstorming session where, we worked together with Indian Institute of Science team and Merit and IISc, both the team. They came out with some product concept and they developed prototyping, proto model. And then it was very heavy, aesthetically it was not proper. Then we tried to assemble electromechanical requirements. Then also it was required to make it smart product by incorporating sensors. So we have got here sensors, 4-5 types of sensors to observe the flow concentration level, to observe the flow quantity, to observe the pressure and humidity quantity, and to observe the temperature as well. And upon getting all these ideas, the sensors are made to emit data or transport data to cloud. And then based on that, the user can take appropriate actions. So this was entire activities from empathizing to prototyping. After prototyping, a real product would be developed, and then we went for testing, and testing 24/7 for 2 months or so. But most important thing for this specific product is time. So during this pandemic stage, we have to ensure that we are meeting the timeline. So which was a key requirement, and day in and day out, we have to work on that in order to get the right product. And then we came out with some design changes, again, going back, if you remember, to empathize stage, and then provided few products for testing to users. And then we changed, like the weight of the product has come down by 25%. So height of the product has come down as well. It is very much convenient to carry it with the user. So this is what is the entire process that involves design thinking and product development. This is one example I thought to pick it up. And in problem solving using data science techniques, we get the data of different forms, be it structured form, be it unstructured, be it semi-structured. Then we have to see like qualitative aspect or quantitative aspect. Then we have a problem in hand. Actually, here in data science, we are given a problem. Say a marketing or consumer e-commerce company wants to improve its selling or revenue or profitability, or they want to create a good marketing strategy or promotion to improve the sales, improve the profitability, improve the customer loyalty. Then the problem is defined. We get the data from different sources, and then we work on that data on different sanitizing aspects, or looking at the anomalies, presence of anomalies in case, and then we take corrective actions in order to remove those anomalies, address those insufficiency in data, and then we select an appropriate algorithm. And we select the model, divide it into different parts, and go for a testing part or training part. Then we train that algorithm or outcome on the test data. Then we see this is what it is coming. So this is what is the ideal cycler activities in a problem solving activity in data science. However, if we go to what we came to know now, that for a problem solving ideas, or maybe when we go for problem solving, we get out of that strategy, we get how do we position ourselves. There are set of outcomes that we need to work out, and then there are some business values, actionable insights that we derive, especially when we use data analytics as a technique. But while design thinking, if we want to understand the root of the problem, like where is the problem that is emanating from, so that is where design thinking is focused. So design thinking is much more broader than this data analytics. So if we go and see here, I have tried to integrate that design thinking portion to circles before that data circle, in order to ensure this is the complete that product development cycle that we need to undergo in order to get a nice product, or maybe an appropriate, cost-effective, qualitative product. And if you see here different steps that we have in design thinking, we have like empathy, we have defining, we have a define stage where we define the requirements, and we talk about ideate, to visualize or maybe to conceive an idea of the product. How does it look like and all. Then we go for prototyping and testing. And after testing, we again go for repetition, again go to that defining stage, matching the requirements, specifications, functionalities, timeline, safety, reliability, all those requirements we froze. And now in data analytics, we start thinking like when we have the data, we have the business problem. We go for thinking which hypothesis we are going to use. Then we see that how do we gather data, be it by using SQL queries or by using this customer surveys or by using this big data Hadoop system, that if we can get from website, get from YouTube, or get from whatever, maybe in oxygen concentrator, there are those sensors, those who give data. So on that data, we work on preparing the data, building the schema, and then on that schema, we work for different, address all those anomalies and ensure that the data is sanitized and as per the requirement. And then in step 4, we go for visualizing the data using different softwares that are available, be it Tableau or be it Click, be it Power BI. And then we go for building an analytical model. So step 4 gives a rough idea, like for example, we want to know the correlation or interdependency of 2-3 variables. That is what we quickly get to know. Well, these are the variables we need to be careful. Whereas in building analytical models, we use those coding softwares available, and then we build the model, we build the training model, we go and apply it on test data, we see the predictability, and we see that which model evaluation or accuracy of the model that we generated, be it based on accuracy ratio, be it coefficient, be it confidence, be it using, more or less confusion matrix, that I can name all those things. Then in case there is any problem, like recently we came across a problem that an investor wants to invest, but this data is showing when he has enough money, he should not invest. So that is contradictory. So we have to ensure that when he has money, he wants to really invest. That is a common sense or domain knowledge that we get. Then what is the anomaly? What did we miss? What do we need to think or clearly look at it? So this is what is the repetition cycle it goes. And it is very similar to design thinking as well. But only difference is design thinking comes up with even more background or more requirement information. So it is said that data science leaders should be design thinking leaders as well. So just to suffice this, this is a company in England, Monolith AI. What they are doing today, this mechanical engineering software that we are talking about, which is the hardcore product development softwares, they have actually embedded artificial intelligence into this. And by doing this, they are trying to minimize the effort, minimize the testing time, minimize the errors, and improving the product development time. So as per them, they see that 70% fewer design iterations are actually required. Like say we are doing 100 times, now it is 30 times we need to do the iterations. And they say that simulation is reduced by 90%. And they also say that reduce testing by 70%. This is how AI is when it is combined with this traditional mechanical softwares. It can end up with decision-making times in minutes. You don't have to wait for months. However, data analytics is a tool. If you think of opening a tap by your hand, how difficult it is. You may end up in opening it up eventually. But well, if I give you a range, how easy it is to open that tap. That is where the data analytics plays a critical leverage role to make our decisions better. And time consuming for product development comes down. Then accuracy level increases by 30%, Monolith people used to claim. So testing time comes down by 70%. So let's see, having said all these things, I want to share with you that how data analytics has been a kind of day-to-day life in different organizations. So I have brought in a video for you from Boeing, how Boeing is using data analytics to their advantage.
What if you could see the future, analyze decisions before you think to make them, and optimize your operations at the speed of light? Information is the ever-flowing energy that powers 21st century aerospace businesses, enterprises, and operations. Operations that generate ever-growing volumes of complex data, where it's hard to know where to look to gain meaningful insight or find the hidden value, until we apply data analytics to make the invisible visible and your enterprise take flight. Aircraft are data-rich platforms, a collection of sensors in flight. Descriptive, predictive, and prescriptive analytics, machine learning, artificial intelligence, neural networks, and data visualization. Boeing Analytics transforms your data into business intelligence, empowering you to discover and leverage new understanding to improve the performance, safety, and economics of your operations. Boeing Analytics delivers advanced, analytics-enabled aerospace products that help you change the way you do business. Boeing Analytics predictive maintenance applications allowed an airline to avoid an expensive schedule disruption. Boeing Analytics Consulting Services uses analytics and innovative modeling and simulation to help customers achieve significant cost savings. And Boeing Analytics-enabled flight and mission planning applications right now are optimizing flight and crew schedules, reducing crew costs from 3 to 7%. With access to unmatched historical data and a century of aerospace knowledge, Boeing Analytics is changing the future of aerospace businesses, enterprises, and operations, helping our customers see into the future today. Because we know it's actually not about the data, it's what you do with it. Boeing Analytics, aerospace intelligence.
So with this, I complete my presentation. I will now, I think once we go for this question answer session, we will discuss more about it. But at this moment, my presentation is limited to this much.
Okay, thanks, Mr. Girish, for the excellent presentation. You explained both design thinking and the data science and the interlinking of the two. Now we are in the context of as earlier principal said, as from your presentation, design thinking process has to be there to empathize, to understand the customer requirement and to make it in a very efficient way, so that whatever on the resources crunch, that also will not happen. So that is what is design thinking process. Everybody understands that it is a systematic way of product development. It can be in several fields. But the problem is data science. Now when the advent of data science and that the application, of course it is fantastic. But when it comes to some of the branches or some of the existing way of doing the engineering of it, it is said that it may surpass, or it may, because of this new area of engineering, some of the conventional area may go. So this is what is sort of, I will not say fear, but there is a sort of confusion with the professionals and all. So our intention was to provide a proper understanding of what design thinking process, no doubt at all, it has to be there. And data science also is a great field. But when we integrate and we do the products, how exactly the two go along, that's what is to be understood from these interactions. So now moving on, I will move in that order of our flyer where all the panelists are there. But let us move on to the presentation, second presentation, which Mr. Pavan Kumar would like to do. Then after that, what I would like to do is put a common question to each one of you, so that from your area, your domain, as well as your area of business, you may throw light on that, like how much it is really making an impact, how much design thinking process you are using in your product development or in your respective business, as well as how much you are ahead in the application of data science in your respective areas. So before going that, I would like to quickly tell I have also come from industry before coming to the academics. So I think two of you somewhere I have come across. Mr. Sunil said he was in Navistar. He had worked for Navistar. So I was also working for Navistar in the design group of Mahindra Engineering Services for Navistar. And Mr. Pavan, I think we Autodesk, our students stood in the national level competition. So that's where we remember Autodesk last year. So they stood national level design contest, they won. So that's what I remember. Okay, so moving on. Yeah, now it is over to you, Mr. Pavan Kumar. So please go ahead, sir, with your presentation.
Thank you, Doctor. And again, thanks to all the panelists for letting me be here. So let me quickly talk about what I think would make sense to all of you. Can you see my screen?
Yes.
Yes, sir. Yes, visible.
All right, so let me try and keep it short and even shorter than Girish could. I hope to succeed there. So first of all, what is Altair? Altair is a company which has had this vision to transform our customers' decision making by leveraging three aspects: simulation, high performance computing, and artificial intelligence. Now, it's a very big statement, but I'll try and explain to you what each one of these does and why they all converge and why they make sense together. Well, a little bit about the company, since I'm paid by them, I have to talk about it. We are almost a $500 million enterprise with 3,000 plus engineers working with us. We are based in Troy, Michigan. We have about 11,000 customers globally. 86 offices, and of course, we also have a very active partner engagement model, which I'm responsible for. Of course, customers range from, since Mr. Shailesh is here, I should point out, yes, Philips is a customer. Thank you, sir, for being a customer for us. And right from life sciences companies like Philips, like Merck, Novartis, automotive companies to the one that Girish spoke about. Boeing is also a big customer of ours. Both Boeing and Airbus are. So we are across the whole spectrum, whatever you can think of. So what do? We actually started life in the top right two boxes: physics, simulation, and design, modeling, and visualization. We started with a preprocessor called HyperMesh. That was the birth of Altair, which became very popular. That helped people prepare CAD models for physics simulation. And then, of course, we branched out, did a whole load of solvers ourselves. And in the process, when we were working with solvers, we realized that there is a huge problem. It's not just about how good you make the software, but how well you can make that software perform on computers. And that is when we did a segue and went ahead into the high performance computing world. We acquired a few technologies from NASA. Now we have bought a few more companies, of course, to make sure that we can get the computers to perform well. That's the whole concept of our high performance computing. And of course, in the recent past, we have added on, through acquisitions and internal developments, a lot of IoT edge computing capabilities, and of course, a very established data analytics company. We acquired a data analytics company which was in the business for almost 30 plus years, a company called DataWatch, and a software called Angos and Panopticon. So we've cobbled together a fairly powerful set of solutions. Our concept was, why did we get into data? We wanted to get engineers to actually use data analytics within the domains of simulation and design, modeling, and visualization. That was the whole idea behind it. And instead of reinventing the wheel, we decided to acquire an existing technology so that it's easier to adopt that into our systems. So these are the three facets that have come together. Simulation, we spoke about, it could be computational fluid dynamics, it could be standard linear analysis, nonlinear analysis, whatever else that you do through finite element analysis. High performance computing, as I said, it's not about just the chips and the computers, but it's about schedulers and the middleware that works on the system to make sure that it performs very well, and the addition of AI on the top. I won't go into this. I think this all speaks about the same circle that Girish spoke about, connectivity right through from, ideation stage to the whole empathy to ideate to prototype test, the whole idea together. HPC is similar actually. HPC is also similar in the same domain. It's all about all of the dots coming together in this space. I want to stress this fact that we are not a hardware company. We don't make hardware at all. We work with everybody like HP, like Dell, like NEC, Fujitsu, Intel, and of course the cloud providers. What do we do in this? We basically, as I said, provide the middleware that helps an engineer do a job submission, not get into complex scripting that most of these computers require. Get the results online, even on his home computer, without choking up bandwidths across the place. The jobs that are submitted in a typical HPC environment are so big that they take many gigabytes of storage. You don't want to lose that in the communication mode. So all these solutions come together to perform that job. Just a quote from the Australian supercomputing folks. Again, just to remind you that these 3 points come together. I just wanted to now touch upon the data analytics piece. What are the key features of data analytics? I would think you can break it up into 3 parts. Again, I think Girish touched upon it. One was the data prep. When you're talking of unstructured data, you need something to get the data to get structured in a specific fashion. Or it could be even something as mundane as extracting a PDF, something from a PDF document into your Excel sheets or into your data prep system. Then comes the machine learning part of it, which is this middle section, the most important piece. And this piece is served with a software called Knowledge Studio. It was earlier called Angos. And it's probably one area which gives you, I would say, accountability through a decision tree mechanism of applying the whole learning algorithm there. And the last piece of it is real-time data streaming. Most people talk about near real-time data streaming, but when you're talking about stock trades and these kinds of applications, you want real-time. And that's where this application works. And of course, the future vision for us is to bring them all into one unified platform other than 3 separate products which we are working on. This is where I had a video to play. I don't think the video is showing up. So I wanted to show you an example of a customer who uses this application for working on data in an engineering domain. Let me find. I have a problem with the way this works. So I think I have to stop presenting first. Then I need to re-present again. Just give me a minute, please. All right, can you see this slide now? Can you see the web page, the YouTube?
Yes,
Yes.
yes, we are able to.
All right.
But audio, no. We are not able to hear the audio part. I think it is okay.
I thought so. So let me quit the audio. Let me just talk through the whole thing rather than show you that. So this was a customer from Mexico called Mabe, which is a part of the Whirlpool group, which makes consumer appliances. They have been using our solutions for physics-based simulation for quite some time. These guys have done a very successful job of producing appliances, but they were having issues with maintenance on the field. So they went the IoT route. They went ahead, equipped all their systems to communicate backwards, but then they had a problem. How do we see this? And they were not a data science company. They were a bunch of engineers who were actually developing it. So how do you apply all this in that space? And that was the whole idea behind it. They actually succeeded very well. In fact, that was the whole example. So I just wanted to end that presentation with that brief overview and give you an idea of how simulation, data analytics, and high performance computing can come together. So thank you.
Okay, thank you, sir. So we will move on. Now I will move on to Mr. Sunil Hailajani. Sir, you are there?
Yes, absolutely.
Yeah. Sir, you have a lot of industrial manufacturing experience and all. So I would like to know from you how much design thinking has been in application in product development or in the manufacturing sector so far, and what is the influence of data analytics in the manufacturing sector? Say, for example, supply chain management, then its impact on other branches of engineering or other branches of business. And yeah, I have supplementary questions to that, but first you may respond to this. According to your experience, how do you feel? What is the level of design thinking process applied in the industries as of now? And what is the influence of data analytics on that? You may please give your opinion in this regard.
Okay, thank you, Doctor. On design thinking, as I think Girish also explained, and we heard in both the presentation, design thinking is a process which has been for ages in our working. Design thinking is not about the engineering design alone. Design thinking is around everything or every service or every product we may have. Even like running a cold chain is a service, or taking care of patients is a service, and the design of a product is also needing design thinking. So design thinking goes into product or process or service in every which way. We are here today to see the linkage or the impact of data analytics. Data analytics is upcoming field which has actually grown over last few years dramatically, as we have started to exploit big data, as we have learned to utilize fruitfully and capture and usefully exploit the data around every service and every product. So this is additional knowledge. When we are designing a service or designing a product, data analytics brings a lot of knowledge. So data analytics is not simply what we do in regression analysis or neural network or and all those tools, but at the end, what we draw out of it adds value to our design thinking. If I am designing a service, for example, patient care or a cold chain or a product in itself, the data analytics will add value to it. For example, the past data of which may be available over a period of say several weeks or several years can give us history, can give us pattern, can give us the niche focus points which are critical for service or design, and those can be implemented. So in a way, it brings knowledge. It is a add-on thing. It is a very useful, I would say, complementing field of knowledge, which is going to improve our design thinking, which is going to also improve our service. It is not at all in any manner replacing or conflicting with our current engineering or current design thinking. It simply brings more value. Of course, it has limitations, as we are today deliberating on both sides of coin. So limitation comes in how you exploit it and how you choose it, and what exactly you focus on. Sometimes you may be capturing data which where data integrity is not high, or which is not very relevant, and if you apply it, it may actually be counterproductive. So design thinking is a fundamental process that we follow in business or in our life, and data analytics is a add-on knowledge area which makes it better and better, and takes it towards perfection over a period. Now you mentioned about supply chain. I think the cold chain itself is a good example, or we can take up any such example where we have big data and that can be utilized to optimize our supply chain, and service design can be according to the optimized supply chain in that view. I hope I'm answering your question.
Yes,
and you are welcome to extend it if there is anything.
I would like to, so from your inputs, what we understand that it is a complementary thing, but not a replacement of something which is existing already there. Like whatever the knowledge we gain, and this becomes a complement. It means I'm talking in terms of data science. Of course, design thinking is a must, it's a requirement. So application of data science, so we can make our processes more efficient, more perfect. But there is a fear that, for example, of course, I will ask this same question to other panelists also. For example, the conventional engineering software, it will go like that. That type of thinking is there in some segments of the professionals, because there are whenever anything is talked, there are two opinions coming forward. One opinion is it will completely go. Another opinion is it will not go. So what is your say on that? You will say the conventional engineering software what we use for product development and all, will it go or it will remain, or it will remain and this will become complementary to that? What is your opinion, sir, on this point?
So these kind of fears have been with mankind since Industrial Revolution. Whenever there is any technology coming, we always fear that majority of the people will lose job, or majority of the current things will become obsolete. But has it happened till now? No. More and more people are required, and more jobs are created. More and more diversification has happened. So any technology brings, if exploited rightly, brings more value to our life, more value to business, and it is for making our life better. So I'm very sure that none of these technologies so like data science is an area of knowledge. It is a application of knowledge, which is finally leading us to artificial intelligence, and I mean through various data analytics and then machine learning, finally going into artificial intelligence. So all this is only going to make our life better. The conventional engineering or the conventional processes will any which way will be required. The knowledge area is to make life better, make life easy, so that people can focus on higher value add things. I mean, the human brain can start focusing on higher value add things and go further. It doesn't mean that we become redundant. Machines will never take over human beings. This is my belief, that technology has to be treated as a very good slave, not as a master.
Okay.
So we have to learn to utilize it, optimally, and make it work.
Okay.
This is my view, sir.
Yeah, perfect. Good take on that. And now I would like, actually the same questions will continue to other panelists also, but this is how I put a preface to that. Now, India is a very populous nation, whereas the Westerners, they are like running shortage of young manpower, and they created all these automation, this, that, and everything, and they say machines are to be paid, for example, and we our requirement is that we need to pay the man because ultimately human comfort, and that's how our life is. So if we are moving to this type of field, for example, now three companies are manufacturing the same product, and the application of data science and all, we have improved our processes such that we are almost near to 100%, not 100% efficiency, not possible, but closer to that. And our products are same. Then will it not lead to glut in the market and ultimately sort of recession? Of course, I understand that data science in some cases is simply excellent. Everywhere it is excellent, but for a country like India, especially in the manufacturing sector and all, using data science and robotics and automation and things like that, when we make it totally automated, will it not kill our jobs? And is it not a time to put some policy in place so that how much man has to do, how much machine has to do? I don't know. It may be slightly off the track also, but this is what comes to mind of the people or the professionals. Especially, you may be seeing that the mechanical engineering, the shop floor type of job, and the students coming, they think several times before joining mechanical. Only the interested will come. Otherwise, a few years back, it was totally different. The scenario was. So that is what to avoid this confusion. If you have some clear thoughts on this, that's what I want to know from you, the panelists. Have I put forward the question straight? You are able to get what I mean to say, right? My question is like when we automate everything, then the machine gets the job, not the man. And in a country, populous country like India, is it the right thing to do? Of course, we increase our efficiency. So there are areas of like governance and things like that may have 100% efficiency. But is it the same thing to be in industrial processes? Because ultimately it may lead to recession. That is what is the question I wanted to ask from you. Please, sir, you may give your opinion in this regard.
No, is it to me? Is this question to me?
Yes, or? Yeah, it is to you, and the same I will ask others.
Okay.
But this is what is the sort of questions we have in our system.
Okay, so to answer your point about students' perception, so there has been a perception for ages about each branch of engineering, which it carries, unfortunately. But over a period, all the branches have become more interdisciplinary, and we are actually converging into various fronts, even not only engineering but engineering and medicine and so many other fields, even social sciences and such things are converging. So over a period, I think there is a need to educate on the on the total canvas of engineering to students before they come, because they are still carrying that conventional image of each branch of engineering, that if you are electrical, you are actually setting up some transmission line, or if you are civil engineer, you are doing some construction, or if you are mechanical engineering, you are actually in shop floor repairing some machine. So that kind of perception has to go, and engineering is a basic knowledge finally leading you to add value to the development by using it. And there is a lot common among all branches these days than it was ever before. And with the interdisciplinary areas, you have much more options in every branch itself to diversify. In mechanical itself, you can diversify into many ways, finally. So I think there's need to educate, and there is nothing to fear. I mean, the fear factor, as I said, has been there since time immemorial. And when computers came, people were worried computers will replace people. When robots came, people were worried robots will replace people. Now it is about artificial intelligence is new fear. So it will go on, but people, I mean, human brain or people will never be replaced, because they have to keep their keep upgrading themselves, keep doing higher value add things, keep getting smarter, and keep improving lives. That is what generation to generation improvement is, and I think that will continue.
Okay, thank you very much. Now we will move on to Madam Ujjaini. You may tell us about the same question, like what are the applications, limitations of data analytics in design thinking, and in your particular area of your own professional area, and in the area of business that you do.
Given so much discussions happening in the mechanical part of it, and as I understand the institute or the department that's organizing, I'll actually focus at this place. I'll give you two examples. Okay. One is in the supply chain, and this is when I was in the e-commerce. One of the very big part of an e-commerce is the supply chain, right? And from the inventory location and when it gets delivered to our end customers, the doorstep, that whole process actually requires a huge amount of design thinking. So if you and as well as the data science, and I think I totally agree that these are very complementary to each other. I'll give you an example, like the last mile delivery, when it happens by a delivery person, right? You must have seen the bag structure that actually has come up. That has come up through our design thinking. And the way the bag is designed, so it has been seen at a very early stage of e-commerce. If you remember, like they will almost open up their whole bag and try to search the product that you have asked for, and then they will search out of so many products, and then they will give it to you. So through data, it has been captured that how much delay was happening because of that, and therefore what is the efficient use of one delivery person that we can do. Then that whole process has gone through a huge design thinking, that okay, if this bag has to be filled, can I fill it in a exact order how it will be delivered? But say the person who has ordered next to you actually has a very heavy product, then the heavy product cannot be placed above your product, right? Or just before you, cannot be placed, because the bag balance will not be there, and the person generally delivers in a bike, so therefore for the safety of the delivery man, the bag balance is also very important. So keeping in all these things in mind, actually human first thought how this can be filled up. Now it question came, millions of such delivery boys are there, and billions of products are getting delivered every day. How this ever can be done manually? I mean, even if you bring people who will every day pack up this people's bag, just this people has to come and put it on their back, and they just go. It is impossible to do manually. And that is where when it comes to scale, human brain has a limitation to how much they can do, they can think, and how many parameters they can process at a time to be able to do this repeatedly. And that's where optimization plays a role, that we know what is the bag size, we know how much it can carry, we also know how many products has to be delivered, what's their weight and dimension, and then the machine and the data science algorithm will actually tell you how this bag to be packed. And then based on that, it comes on the screen, and then a person just without thinking much, dumping in the bag, the delivery person comes, put the bag and go. And he doesn't need to search. He just goes to your doorstep. Exact product is just at the top of his bag, and he just come and give it to you. So that reduced the time to delivery, that improved efficiency, that improved customer experience, that improved everything, right? So I think, exactly design thinking and data science were used together. I'll give you another example in actually manufacturing, and this is about the car engine manufacturing. So there is a huge assembly line that is there when a car engine is getting manufactured. Now, if And there are some people who actually listen to the engine sound at the almost at the end fag of that assembly line. These people sit and listen to the engine sound and figure out if there is an anomaly or if there is a problem in that engine and be able to capture. Now imagine these people are very specially trained, and what you are using is a human hearing capability. These people, when they come in the morning, has a good hearing capability, they can identify. The subtle changes over the day after lunch, it becomes very difficult for them to capture. And one, costliest car's engine doesn't play well, it's a huge value loss for the brand, value loss for the people. So then the question came, can artificial intelligence actually determine, or data science can actually determine this kind of anomaly? The immediate question, and I know I'm connected to one of such organizations who actually has built this acoustic artificial intelligence. So it actually listens to all the sounds as the process of the assembly line, and way before it is there, it kind of picks up if there is a challenge in the in the production of the engine or not. Now these people didn't agree to buy this software. The pure reason is they first thought that it is going to kill their job. This whole AI system will identify where there is an anomaly, where there is a defect, and it will be able to do their job. But then, that is where the empathy comes, and that is where we realize that machine can figure out an anomaly, but maybe that anomaly is still okay to go ahead. And if you have to train the machine till the end level, it becomes very difficult. It becomes way more cost compared to what you are paying to a human, and that is exactly where it comes. So that is where a handshake happened. It said that, hey, listen, we are not going to make the AI 99.99% accurate. We are going to make it probably 80 to 85% accurate. So the human need not listen to all the sounds. It will at least figure out which are all good. So for them, you don't have to, waste your hearing capability in the day. But only when there is a doubt, it will go to you, you listen to it, and you identify if this is, really an anomaly and it should be actually discarded. So then it almost reduced to 20% of the engines only go through human, and that's the hybrid method. Third example I'll give you in a translation, and this is a huge place. In translation, in the Western languages, actually the AI-based translations are working well. When in India, for the Indian language translations, any translation AI going to sell their product, the first thing they're getting hit is, today human translators in India are way cheaper. Why should I even pay for a machine translation? And therefore there are pockets where human the human job is way cheaper, and India will face a challenge. And that's where in design thinking there is another thing which is called reverse innovation. So there are, if we just have to copy what West has done and has to bring in India, it may not work. We have to think through what is an Indian innovation that has to work for Indian people, for Indian requirement, and then figure out a better solution. I think that's where a reverse innovation has to happen from emerging country to a developed country. I hope I could answer your questions.
Excellent, madam. You answered very well. Actually, what are process improvements? I do agree with you, because as I told you in the earlier job, I had seen, like, for example, crankshaft manufacturing line, they used to have these type of defects. I used to always think, like, of course, I left industry long back, some 7-8 years back. Recently, when I am in the academics, coming across this influence of data analytics and things like that, I used to think, oh, in that crankshaft line, we can have this type of technology so that we can reduce the defect. Now, similar thing what you said about engine and all, and also fantastic way you covered. This is what the question I had, like at some point in time as compared to the West, because the West salary levels are much higher at the lower level also, whereas in India it is very cheap. So the machines may become costly. So this is where the break even or whatever what you said, there will be a fine balance. So that is what the question we have for the panelists also, like artificial intelligence or machine, whatever, this influence of this in the manufacturing sector, it may become expensive is one feeling. I think from your, the way you told, it looks like so. So you said reverse innovation, and we have to do it adapted to our country. So we should not straightforward copy. Actually, that is what is happening. We straightforward copy and talk, and in the process we may lose. So that is where I think it is a fantastic input you gave, madam. Good.
Thank you.
So yeah, I'll move on to Mr. Shailesh Agrahari, and sir, you may speak about your experiences of design thinking and data analytics in Philips. Philips is a great brand. So, of course, all are great brands. Means why I'm saying great, because some of the things, household items we will have. So Philips is one item at home. So that is the way it gets connected with the brand. Yeah, please go ahead.
Sure, Dr. Shashi. First of all, thank you to all of you for sharing wonderful insights. I learned quite a lot. I'll briefly share some of experiences. In Philips, we are a health technology company and focused in the improving the people's lives. Whatever we create, we need to keep patient in the center of everything. We need to understand patient very well. That is the first step of design thinking. Yeah? You need to understand your customer very well. Now, imagine some of the example given that how I can understand our customer better. Can I utilize data? Can I utilize AI and so forth? Now, imagine that I have this thousands of MRI machines worldwide, one machine in Japan, one machine in India, one machine in US. All these customers, are they using the machines in the same way? Are the patient's structures are same? Do I need to redesign my things as per the needs of the customers in different geographies and so forth? And how sitting in Pune in India, how I can understand these different types of customers? So these thousands of systems are there in the field. All those are remotely connected through cloud, and I'm getting all the log files sitting in my lab. Imagine the power of the data science and analytics. I can map the user behavior, the ethnographic studies I can do completely sitting in my lab. I can see, analyze how different customers are using my systems. I can understand their behaviors. And I also can understand the challenges that they are facing. For example, let's take an X-ray machines. You might have gone for your some chest X-ray examinations and so forth. You will see there is an X-ray tube which goes and positions on your body. Somebody is moving this around. And in the background, a lot of events are happening, and I'm getting a lot of events generated there. When you move this, sometimes you repeat the operations. You are wasting time of the technicians there. And those events, I can log this, and I can say that how I can improve things. Yeah? So those kind of deep analytics we can get sitting in our labs. That helps in overall design thinking, product development. And when you know your customer better, you can ideate better and you can solve better. That's just one example I'm giving you. You also asked whether AI and machines can replace humans. I do get these questions all the time. Would our machines replace radiologists, for example? Doctors, will it replace doctors? They also get scared when we come up with some AI analytics tool which can analyze and find anomalies in our imaging data, be it X-ray, be it MR, be it CT machines. They would also get scared, would it replace it? But as Ujjaini ma'am said that AI can bring sensitivity, specificity to certain level only. But still, even if it is 99% accurate, you still have 1% chance to go it wrong. And imagine if I make a wrong decision and give a wrong treatment to the patient, I'm endangering the life of someone. Yeah? So human intelligence will always be needed. And Mr. Sunil has already said, right, we have gone through many such evaluation, and every time if this question comes up, I'm sure what we still need to do, a lot of students are there in the call. My message to them would be, yes, things are changing. We cannot continue within the way how we have been learning. We have to upgrade our skills. We need to learn new technologies, and we need to start applying in different domains. If I'm a mechanical engineer, I still need to understand how AI works, data analytics works, and I need to apply in my domain. So we need to continuously learn and upgrade our skills and learn how to expand our field and do better and better there. So for everyone, I see there is a space. And if we have the culture of continuous learning, we will all have a good place in the society.
Yeah.
I hope that answered the session.
Yes, you have put it across very nicely, sir. So, each of the panelists have really given an insight, like where we stand and what we need to do. It is simply excellent. You have also put across so nicely, sir. Now I will move on to so a sort of with the panelists one round we completed. So there some of the questions are already answered actually. Now in a way I will deviate from a bit here. I will ask other questions also a bit later. Now with respect to the presentations by Mr. Pavan Kumar and Mr. Girish, Mr. Pavan Kumar sir, you tell us you are a great company Altair. You are making engineering software, and this software, you know, like as we see, we are from industries, we see that any product development in the conventional way, how you produce, of course, with the advent of FEA and such as CFD and all software, if the engine manufacturing means product, I am saying, or the vehicle as such, if it was taking earlier 4 years, it is cut down to 2 years, or the engine earlier 2 years, it is cut down to 6 months. This is what is happening in industries because of the advent of such great software. You are a part of that. Now, my question is, I earlier also I asked the same question. So you are integrating data science in that. Now I am asking, and this confusion comes from the industry itself. Because we are in college, so we come across a lot of our graduates who are in industry. So alumni. So from different sections, we understand that in some companies they are like going fully for this data related thing for product development, where there is a fear that this may go. But as a software manufacturer, you yourself, what is your take on that? Your software, because you know, see, it has evolved not suddenly now, all of a sudden. It has taken 100 or more years. Software came later after the computers and all. But the product we developed not so easily now. Engine took nearly 150 years of perfection, and that perfection we were not up to perfection till 20 or 25 years. Of course, this software and all help like anything in making engine a perfect piece of high power, low emissions, and compact. That this software and all things have helped. This data and everything has helped. Even our engineering software has helped considerably. Now, what I am asking, are those engineering software which has helped in making this so well, and it has happened over the years, not all of a sudden. But when we talk of data, people are saying it will suddenly happen. What is your take on this?
Good question, Dr. Shikant. I think the answer came from everybody. It was similar. Nothing replaces anything else. They all complement each other. So let's look at the ideation phase, since you mentioned that you are from the automotive industry, crankshafts and other stuff. What is the key requirement from any OEM? So the key requirement is weight management, right? It starts from that first step of the process. So when you look at weight management and you're still without any prototype, you're still on a CAD system, you just have the 3D CAD with you, and you want to figure out what is contributing to the increased weight. And when you have thousands of such systems in a larger assembly, you can't go about using conventional techniques. You cannot identify it with an Excel sheet. You can't find out which of the componentry added to this and who was the supplier for that. There's a whole big analysis required for it. Oftentimes we used to ignore that in the past. We just used to focus on using lightweight material and hope that we achieve what we want, right? That was the past. But nowadays, there is the ability to apply data analytics to this weight management story, where you are actually complementing the efforts of the mechanical engineers to reduce the weight or come to a certain target weight that you want to work on. Same way, in the design process, when you are doing the design, you also need to have certain decisions taken. If you can reduce the number of, say, crash analysis in an automotive design domain, today a typical crash analysis takes you 4 to 5 days of the supercomputer time. Can we afford that? Can we reduce the numbers? And if we can bring it down, I think Mr. Sunil mentioned it, instead of doing 40 prototypes, can I bring it down to 10? You can obviously reduce that. And today, AI, ML, some of the programs are actually helping many of the analysts and engineers reduce that. And the last part of it is in the life cycle of the product. What will you not give if you don't have a breakdown of your car at all? What if you can have somebody predict that, Dr. Shashikant, please stop the car now, because if you go any further, you'll have a breakdown. And that is what IoT is doing today. It's helping you do predictive and prescriptive. They'll probably also go to the next stage as saying, instead of driving at 60, please drive at 30. It will not break down. That moves into the prescriptive domain. And that whole area is, I think, it's a complement. It's never a supplement. That's what I would say.
Sir, excellent. Now I want to know whether this will become complementary to your software, whatever you have developed are in use, and further development. When it is done further development, you will be doing including the concept of data analytics in that. Is it like that, complementary to it, or it is in isolation?
It's complementary to it, and as well as an addendum to it. Okay. So when we say complementary, let's look at finite element analysis, Dr. Shashikant. It's about mesh generation, right? And what is meshing? Meshing is a very mundane task of subdividing something into, elements that you can deal with. What if I can apply some ML program to that and make that mesh a little more faster and more easily solvable? So we actually use it today in Hypermesh. So
that software will remain, and this will become complementary, or it will become a module?
Everything morphs over time. The CAD software that we used 20 years ago is no longer the CAD software that you see today. It can do a lot more. So they all morph into a better solution for you.
Yeah, excellent, sir. You have also given an excellent explanation regarding to come out of, of course, it has emerged that not to have any fear. Time immemorial, that has been there every time at the intervention of new technologies coming. Some conventional way we feel that fear, but we have to remove and move ahead. Moving on, Mr. Girish, I would like to ask you, sir, you have touched upon fantastic, your presentation was so nice, and now I want to ask you, when answer is there already, but still I want to ask you, in the aerospace sector, already answers have been given by Ujjain madam and by Shailesh sir, that answer is there, but still I want to ask you this question, that what about in the aerospace sector, how much we can rely on data science, whether can we forego testing of some of these components, because in the automotive sector and all, what I am hearing, they forego some of the testing direct from design to production. Is it possible the same way by the intervention of data science in aerospace sector, in the manufacturing of aero parts, can we forego some of this without testing?
Okay, very good question. And in fact, all of us, we are talking same thing. It is a complementary, but nevertheless, we are, just imagine 50 years back, 70 years back, we didn't have any CAD software. We didn't have any CAE software. So how we are doing product design? We are doing product design manually or some other ways. But then soon CAD software came. Then finite element analysis software came. In fact, in finite element softwares, there were advanced softwares fluid structure interaction kind of software. Then it became an addendum. Then further data analytics is coming. We are going to an addendum as well. So it is refining the product development process. So from say 1 year to 7 months to 6 months to 5 months, or maybe the accuracy level is increasing or improving, test timing is coming down, number of errors is coming down. So this is all is the outcome. As I said, both these not only this aerospace as a business or product, even our CAD softwares, CI softwares can emit or generate lot of data. One node in a mesh or in an element, 4 nodes, they will have say 8 degrees of freedom each node. Then it becomes how many degrees of freedom? So it becomes huge data set. So like that in IoT, using sensors, so we get lot of data being generated. So when you get data, you work on that, you analyze. So something I am giving you a kind of range to open your tap, rather opening it in your free hand. So I am providing a tool which is using scientific methods that are proven and established. And using that, how can you really do that? But eventually it is human beings, those who are superior, nothing can replace. So one thing, one set of functions, when they are being managed by machine learning or robots, then we become like, we have to go to the next level of knowledge, next level of jobs, next level of expertise will come out. Now coming back to aerospace domain, can we really get out of or get rid of some testing components? Answer is no. But how do we do that testing? That is where actually the things are different, or new things, technologies are coming. So we are not knowing that this spectrum of this random forest data, which we are talking in data analytics, that is the kind of noise we get from aero engines. So how does it, like the load when it goes, airplane flies, we get continuous wind loads. So that spectrum is huge, like it goes up and down. So we call it random forest in data analytics. So that is only a technology or technique that we can use in order to improve the existing process, improve the existing methodologies, improve the accuracy level, and then see how we can minimize the product development life cycle in a holistic manner. So to make it a more refined and better product with better accuracy, to make our life more easy. So it all complements the entire things. That is what is my...
Okay, sir. I wanted to know, like, this spark testing, 100% testing will continue at least for some time till we know the complete newer technology.
It may not be 100% continue. I mean, there would be reductions because new methodologies, when they are getting implemented, the process or the method may change. That is where things will change. It may come down. How much it will come down, to what extent it will come down, we have to see. Depending on application, depending on platform, we have to see that.
Thank you very much for all your great inputs. Really, it has given a lot of clarity today. And I want to know, this is a general question to all. Since there are so many questions which have come up even from participants and all, but now we are running short of time. So I will generalize and put it in a common form of sentence that now we are in an era of, we are talking of global warming and climate change. What do you think in the context of global warming and climate change, as Madam Ujjaini has said, at some level people will become cheaper than machine. So similarly, when you are talking of global warming and climate change, if you are going to have complete machine usage and all, what is the power situation, and will it add to the global warming climate change, or will it bring it down? And what is our using all this technology, can we not make the products which are having low carbon footprint? So each one of you may answer, starting from Mr. Sunil. Sir, you are there?
Yes.
Yeah.
So the data analytics as such is going to optimize the process, as we spoke, and any optimization of process or design will finally lead you to better and more efficient utilization of energy or resources. So that will be helpful.
But when we are using machines, are they going to have a lot of like high powered machines and all? Is it when we talked in the context of India, for example, where manpower may become cheaper with when compared to machines? Similarly, is it that we may reach a level? I don't know whether it's the right question I am asking here now. But somewhere I have come across like that also. The machines may become more energy consumers, and that is where things may have problem in future. What is your take on this particular question?
So your question, if I've understood correctly, whether machines will become more dominant and will consume more energy, and whether manpower will become less important. This is what you are saying. So my view is, irrespective of third world countries and developed countries, the difference you see today, this differential is going to reduce over a period. This is a temporary phenomena. Of course, there will always be gap, but then the low cost worker or low cost manpower is a temporary concept. Over a period, this will go, and the cost of manpower is going to be reasonably high, and automation or use of artificial intelligence or use of more and more autonomous things will become even economical. And as I said, overall use of energy has to be optimized by various means. We are getting into two level of actions. One is the generation of energy becomes more sustainable. Second, the usage of energy or recycling becomes more sustainable. I think both the fronts we have to work. The first front is to have more renewable resources. Second is to efficiently deploy it. And efficiently deploy it means usage of more public transport, usage of more such activities which are generally efficient, and high productivity machines, resulting into low energy usage per product. So eventually, every technology, I have a firm belief, leads towards better life, leads towards more efficient solution and more economical solution to reach out more people and making everybody's life, upgrading everybody's life. If it is not, then technology is not worth it. So, in a way, if we say technology coming and replacing people, or technology coming and becoming expensive, or technology coming and making our life worse, then the technology is not sustainable and not worth it.
Okay.
And I think data analytics as a field is still at nascent stage. We have still to learn a lot. Compare with the human brain. Are we anywhere near that? No. So we have to actually work a lot and evolve this field as a tool of knowledge. This is a tool of knowledge that can transform our lives, and really it is going to make it more meaningful, more beautiful. This is what I would say.
Okay, thank you very much, sir. Anybody else? Now I will not ask the same question again. Anybody else would like to add on here, or then it's fine?
I can just say, add something more. By nature, human beings are very lazy, and by nature, human beings are very greedy. So these are the two things which will, anything once you get habituated, reverse habit building becomes very difficult. So once you get habituated with a machine, it becomes so difficult because of the inner nature of laziness. It becomes very difficult to come out of it. Okay. So there, for example, when we talk about the cloud system, there are huge data centers which are coming up everywhere across India and across the globe. And these data centers are actually energy guzzlers. The amount of electricity that it consumes, because it needs to be kept at a certain temperature, and it needs to be certain maintenance, which becomes really, really difficult. And that where I think the use of the renewable energy, and one of the very big field of design thinking and innovation is being able to design sustainable products and being able to design environmentally products. I think the consumers also somewhere needs to be little bit conscious before we use such technology and accept such technologies in our life. I think it's a dual responsibility, those who are designing and those who are using. I think together we should be able to make it a better world.
Excellent, madam. Simply excellent. You are very correct. If I'm
Yeah.
using a washing machine, will I go back and do the conventional way of washing? No, I will not. You are right. Perfect. And as you said, that we have to two ways we have to think. Am I making in a sustainable way? That is the thinking has to come. Very correct. Yeah. Yeah. Please.
Yeah, if I just add, yes, I think sustainability has to be core when we design something, use something, and also bringing more circular economy concept. We also need to think about it when we have to, let's say, something becomes end of life, how we can take that product back and recycle them. So that concept has to come very early on during the design phase, and consumer also needs to propagate this more and more. They are reusing sustainable products. That's how we can make the our society green. Yeah? So sustainable products comes with the utilization of eco components and green products, and so utilization of green products components in our design, as well as bringing the circular economy. I would say when you are able to recycle our products through your design, that's how we will make this world sustainable.
In my opinion,
Doctor, if I may interrupt, and add one more small thing after hearing Ujjaini ji and Shailesh, that sustainability in any which way is a major point which is required. So if data analytics design thinking has to move its focus towards things which create larger impact in society. I mean, there are products and services which bring larger impact in society, and there are some luxury segments which bring actually which bring impact only on a very select segment. So more and more we work on larger impact factor and products and services that will actually help us in terms of promoting not only data analytics, not only artificial intelligence and its applications, but also creating much better value, as we just spoke about, reducing disparity in life and also bringing better life. So this is my point.
Okay, great.
So I was telling few points. See, the energy-wise, if you see, renewable energy is becoming very prominent subject today, and in few years, like many companies have promised by 2030 they may have all electric vehicles. So like that, renewable energy will take place, the help of conventional sources. Again, the carbon footprint may increase unless we take care of the product. When we are designing the product, we have to keep it in mind. As Shailesh told that, okay, recycling, the complete ecosystem has to be established. When the product battery is over, how do we recycle is very important. Just imagine the number of mobiles being wasted or being thrown away every day. I mean, how do we recycle it? How do we make reuse of it? So that will be a challenge. We have to work on that continuously.
Yeah, thanks, Girish ji. Actually, it is the word sustainable has to replace everything. Not even renewable is the solution. Renewable has to become sustainable. Then only we'll have a sustainable living for the future. So with that, you have all put in your lot of time. I think I will conclude and then we will move forward. Is it okay? We'll summarize quickly.
Okay.
Okay, I will just read out what summary I have written. So, as Sunil sir has said, don't worry, time immemorial fear is there, but new technology comes and it helps, like human comfort will keep on increasing. So, it is new technology is complementary, and we have to have multidisciplinary things, like students have to be told how each branch is essential. All the branches are required and everything is on a multidisciplinary role. That is what students have to be given a proper knowledge of that. Then coming to Ujjaini madam, she said at some point in time, cost of manpower may become cheaper than the machines, and there can't be 100% process which is 100% through this data analytics. Of course, it will help us, but we can't take it for granted 100%. That is where the human brain comes into picture. And what she mentioned, very important, is don't copy the Western. We are not discriminating. We are not saying that. We are saying like don't copy their culture. Everything is different. So don't copy their thing here. Instead of that, you do reverse innovation. Then what Shailesh sir has said with respect to say patients. Understanding the patients all across the globe with the help of this data science has been so easy, and it has that what is that called empathy. We can understand what is the requirement and all. And he also made a point that even 1% mistake happens with that, and that can be the death of the person with the medical thing and all. So that is where human will have the ultimate thing. Decision maker will be the human, not the machine. That's what we understand from this discussion. And what Mr. Pavan Kumar sir said, also he said like as others have said, it's complementary. For example, he said how we make use of like weight reduction in the vehicle is the most important thing, because once the weight reduction happens, the fuel consumption comes down. So in the conventional way, we have not been able to reduce the weight of the vehicle, for example. Then this data analytics will help substantially. For example, crash test and all, it would be very complementary. That's what he said. And also he said this software are not going to go, whatever the conventional engineering software, whereas these new things will be built as an additional module, so as a complementary thing. And Girish sir has said in the aero domain, as of now, it is going to be complementary and 100% part testing. Whatever is there, till any new technology is developed, it will remain. Yes or no? That is what you are muted.
Testing will remain, but number of tests required or time for testing required will come down, or maybe there would be advanced methods. Say today we test the wing in wind tunnel, so there can be another ways that different methods that we may have to go for.
Very good. And when it comes to the power consumption and all with the machines and how we humans behave, it emerged that we have to also really have. That's what in the design thinking process, empathize is there. So we have to, each one of us have to empathize with the nature as well, so that then this thing will not be, these difficulties will not be there. Then we'll be in the sustainable mode. So when we use sustainable everything, I think all our problems will be solved. With this, I will conclude this particular discussion, fantastic discussion, and really you have given a lot of clarity. And I'm extremely happy with this all the discussions with all of you are experts in your own area, and you have given clear insights about what, where, and all. So let me now go ahead with the vote of thanks. If it is okay with you, if you have anything additional to add, you may add. Otherwise, I will go with the vote of thanks. Is it okay? Or Thanksgiving, whatever we may say. So let me take it through. First, to start with my principal of NMAMIT Institute of Technology, Nitte, Professor Niranjan Tiplunkar. He gave a good opening remarks, and he was there for some time up to 3 o'clock because he had another meeting, so he had to leave. So I am gratefully, thanking him on behalf of us from the institution's Innovation Council. So thanks to him. Then going by that order, in our record, I take this opportunity to Mr. Sunil Pahilajani, sir, Executive Director, High Tech Gear Gurgaon, for spending your valuable time and giving the insights about these two twin topics. And we are really grateful to you, sir. And coming to Mr. Girish Samal, Head Sales and Marketing, Merit, Bengaluru. Thank you very much. You started with that excellent presentation. So, and thanks for bringing all these great experts here, really. And really, he has put in a lot of time and effort. And because of that, it has been possible. I must really, from my heart and on behalf of all of us from NMAMIT Institute of Technology, thanks to you a lot, sir. Okay, thanks. And moving on, Mr. Pavan Kumar, sir, Senior Vice President, Altair. He had to leave a bit early because he had another meeting. But in his absence, I am thanking him for giving his valuable suggestions or valuable opinion in this particular panel discussion. So I thank him on behalf of NMAMIT or Technology Institutions Innovation Council. Coming to Madam Ujjaini Mitra, Madam, you have really put across like your experiences and all, and as like human behavior, what we need to do and all. It's a perfect thing what you have said. And now we are talking a lot about human behavior because you may be aware that All India Council for Technical Education has brought in a new course called Universal Human Value. What you said, everything is there in that course. How to be harmony within oneself, harmony between the two, harmony with the society, harmony with the nature. It is not only ecology; it is above ecology. Yes, it has compulsorily brought under the new education policy. So whatever you said, it is there. Okay, thank you to you. Thanks to you, madam, on behalf of all of us here. Thank you very much for sparing your time. And sir, Mr. Shailesh Agrahari, thank you very much, sir, for spending your valuable time with us and giving the valuable inputs to our panel discussion. Really, we are grateful to you. Thanks to you. And I have other people to be thanked. Let me quickly go through that. We have our own Dr. Anil Kumar HS, is the President of Institutions Innovation Council of NMAMIT. As told earlier, this Institution Innovation Council is a requirement by the Government of India. So we have that council, so he is heading that. He is from Biotechnology Department. So today he is in another training, so he couldn't attend. So I thank him on behalf of us. Another colleague of mine who is also a colleague in mechanical department, Dr. Ajit Hebbale, he is associate professor. So thanks, Dr. Hebbale. Then I fail if I don't thank Miss Ankita Naik. She is assistant professor of computer science and department, computer science engineering department. She was the master of ceremony in the initial beginning. She started the program. So I thank on our IIC behalf. Then behind the scenes, a lot of people have worked. For example, Mr. Krishnaraja Joisa is the PRO of our institution. So he has helped us in consolidating, making the flyer and things like that, and even giving the YouTube link and all, and virtual background also he had given. So I am really thanking him on behalf of IIC and on our behalf. Then we have Mr. Satish Naik. He helped us in putting it across social media such as LinkedIn. And I fail if I don't thank our participants who have heard about this discussion, and we provided the YouTube link. So I thank all of them for being here with us and taking active part. I would like to tell you like the participation from all across India. So what I saw, IIM Ahmedabad or likewise from different states and all engineering or even medical. Medical and dental. These institutes also represented in this discussion. So I thank all of them, and thank you all, sir and madam, for being with us and spending your valuable, providing us with the valuable input. Thanks a lot.
Thank you very much. We are delighted, in fact. Thank you.
Thank you.
Thank you. Bye.
Thank you all. Ajit, I'll end the program.